Before we talk about the third possible method that you could apply to solve the roots or the solutions to the quadratic equations, let us talk about this simple process that is actually needed for that method. I'm going to share to you another practice exercise. But again, it's not yet on solving roots, but we are actually going to talk about one of the vital methods or vital part of the next method. Here, we are asked actually to complete here this expression so that we could come up with a perfect square trinomial. As to why do we need to get a perfect square trinomial, just wait. It will be captured by the next video. Don't worry about that one. We have here quadratic expressions. You have C, as you can see, we have here x squared, x squared, x squared, and 2x squared. So we have here a given all of these given here are quadratic equations. So this actually, again, this process is a vital part of finding roots of quadratic equations. So we are going to talk about making it a perfect square trinomial. The perfect square trinomial is actually an expression that later on you could express in terms of x plus y squared. Okay, or let's not use y so that you will not be in confusion of why is it that there are two variables there. Still, this is still a variable, but this is actually a constant. So we could express it in that form. If we could come up with a perfect square trinomial and then we could express it in this form, we could actually apply later on the first method, which is extracting square roots. Because again, in extracting square roots, we could actually use it if one side is already expressed in, let's use d, in a given as a square of binomial equal to any constant. I'm just labeling it here d. So we are going to still use the extracting square roots. But first, let's talk about perfect square trinomial. We are going to, in short, we're going to, the term here is we're going to complete this expression for it to become a perfect square trinomial. Okay, and how do we do that? There is a formula for that one. I'm going to present you the formulas that you will be guided later on how do we solve that one. Okay, so we are going to actually, I'm going to give you the formula and let's try to check later on if it's really correct. So we are going to take a value of c because a here is actually 1, a is given, b is actually 8. We need a value of c which could actually make it a perfect square trinomial. So we are going to solve for c. So the formula goes like this. The value of c is actually the square, okay, the square. When we divide the value or the coefficient b by 2 and then square root of the value of a. Other references do not use anymore square root of a, but I'm going to use it since there are actually expressions that values of a, just like in number 4, is not equal to 1. So this is actually the formula in getting the value of c. And since it's square, we always expect that the value of c here is a positive because the square of any number is always positive. So I'm going to just simply write here positive signs. Let us try to complete this using this formula for number 1. A is already 8, B is, I mean, A is already 1, B is already 8. Let's try to substitute. So the value of C here is the square of 8 over 2, and then square root of A, which is 1. So you have here square root of 1 is 1, times 2 is 2. So 8 over 2 is just actually 4 squared. So the value of C here is should be 16. So I'm going to place here 16. Right? How do we know that this is now a perfect square trinomial? Right? Let us try to look at the given expression. I mean the formed expression. The first term is a perfect square of x. Right? The last term now is a perfect square of 4. When we are, let's try to have a short of a review in your previous grade level. We could actually tell if a trinomial is a perfect square trinomial if the first term is a perfect square. So a perfect square. The second term, I mean the last term, is also a perfect square, and the middle is 2 times the root of the first and the second term. the square root of the first, and the square root of the third term. This should be what will happen in the middle. Again, so one is the first term is already a perfect square, so it satisfies. The third term is already a perfect square of 4, so it satisfies the content. So let's write this for the middle. 2, the square root of the first term is x. The square root of the third term is 4. 2 times x times 4 is actually, that's times 2 times x times 4 is actually 8x. Positive 8x, so it satisfies the middle. Therefore, this is already a perfect square trinomial. Now that this is a perfect square trinomial, since nevertheless, even if it's not given here, this now can be expressed as a um, square of a binomial. And how you would do that? If you are now sure that it's a perfect square trinomial, you could just simply take the root of the first term, x, the root of the third term, 4, and the sign of the second term plus. So this is actually a product when x plus 4 is squared. So you might want to check that out. This is just an additional, okay? I'm just presenting this as additional task since ang task na naman natin dito is to complete it in a perfect square trinomial. This is also another task, but to check whether this is already a perfect square trinomial or not. So let's have number 2. Number 2, our A here is 1. B here is negative 12. Please take note of the sign. It should be negative 12, not just 12. Let me erase this here to remove confusion. Yeah. And then let's solve for C using a formula. C should be B, which is negative 12, over 2 square root of 1, which is the value of A. And then you have squared. So 12, 2 times, the square root of 1 is 1, times 2 is 2. So you have here 12, negative 12 divided by 2 is negative 6. And you have to square it. So C is actually positive 36. So we could actually place here positive 36 for it to be a perfect square trinomial. Checking, use this. First term is already square. The third term is already a perfect square. So let's look at the second term. This should be the second term. Second term, so that we would know whether our trinomial is a perfect square trinomial. So it should be 2 square root of the first term is x. The square root of the last term is 6. So 2 times 6 is 12. Okay. Um, and then 12x. Okay. It's 12x right now, but don't worry about the sign here. We are just looking for the value. Uh, squared, again, the square root of 36 can be positive and negative. Okay. So you have those value 12x. So this is already actually 12x. So this is actually a perfect square trinomial. Okay. So let's proceed with number 3. I will leave checking to you. Okay. Let's just complete it. Right. So you have here x plus 4, and then your A here is 1, your B here is 4. So let's solve for C. C is negative 4 over 2 square root of 1, and you take the square of it. So that's 2 squared, which is actually equal to 4. So you have here 4. And then you check it, determine whether this is really a perfect square trinomial or not. Let's skip with number 4. Number 4, the first coefficient is 2, the second coefficient is negative 8. Okay, so let's determine the third term here. So it should actually be equal to um, negative 8 over 2 square root of 2, as this is the value of A. This is where it gets different, because earlier it was all 1, 1, and 1. Right now you have here 2. That's why always consider square root of A, because other references will not place A, but it matters now if the first the leading coefficient is not equal to 1, and then you square it. So this is actually, you can divide this. So you have here You cannot extract 2. We just simply divide um, the coefficients here. So you have negative 4 over square root of 2, and then you square it. Using the law of exponent, you have positive 16 over the square root of 2, which is 2. 16 divided by 2 is actually 8. Lots of exponents tell us to share this expression. So it's actually equal to 8. So this is actually how do we complete a expression or complete the perfect square trinomial. And then we could actually express it later on into an equivalent square of a binomial. Right? So you have this expression. This is now, don't worry about the negative here because once it's 36, you could actually express it now into an expression x and then square root of 6, which is 36 is 6, and you simply use the sign here. Okay. Just using here the method, and if you have heard that short mnemonic technique, square square multiply double, right? Again, square square multiply double. This is to verify whether our answer is here is correct. Our value here in absolute value is actually equal to the middle. So checking here, you could also check the square root of x squared is also x. Well, won't we try? Let's just try na lang to complete this one. So you have here twice the square root of x squared is x, and the square root of 4 is also 2. So 2 times 2 is 4x. This means it's satisfied here. But for the second here, you have the twice the square root of 2x and the square root of 8, which is actually 2 square root of 2. Okay, square root of 8 is 2 square root of 2. So you can see square root of 8 is actually equal to square root of 4 times 2. Okay, part of your lesson in the previous grading. So you have here 2 times 2, which is 4, and then square root of, I'm sorry, this this is 2x squared. Square root of 2x squared, because it's the first term. So yeah, you can remove it outside. So you have 4x square root of 2 times 2, which is 4. So square root of 4 is 2 times 4. So you have here 8x. So you have here the same value. The negative sign later on will be covered by the square of binomial. Again, this is just checking. This is just checking. Just to clarify, number 4 here is actually not yet in a perfect square form. Because as you can see, the first term is in a perfect square. The third term is not also a perfect square. But they have the characteristic for it to become a perfect square because again, as we have checked here, it satisfies the concern of perfect square trinomial. How do we make this a perfect square trinomial? We could actually factor out 2 and we retain x squared. Factor out 2, we'll have 4x. And factor out 2, we'll have also here another 4. This is what actually our perfect square is. So as you can see, again, we are actually completing here the perfect square trinomial, but when you look at it, it doesn't necessarily apply as a perfect square. But when you take the common monomial factor, which is 2, you can see there that it contains a perfect square trinomial. So for the next video, we are going to actually just contain this learning and then add it as part of the method later. Okay? So we are going to use this as part of the third method to represent it in the next video. Because the third method is also known as the completing the square method, where in case we cannot use the square roots methods because we have the big coefficient, and then we cannot factor it because it can't be factored. We can use the factoring method because it can't be factored. So if those two conditions are met, again, we cannot use, there is a B coefficient. Second, it cannot be factored. We can now use the third method, also known as the completing the square method, which will use this content. So please be excited. The next video will be coming later. Goodbye.